Hey gang, welcome back. Let's talk about inventory planning. We're on session 2 and we're going to talk about lean and ABC classifications right here. So good stuff, stuff you probably already heard of a little bit, but let's just delve into it a little bit more and do a little deep dive in here and see if we can come up with some good stuff to help you pass the test and move on with your studies. So talking about lean manufacturing, I'm on slide 225 and it talks about lead times. So the problem with long lead times, and you guys as production professionals, material planners know, long lead time items are always a pain, right? They're hard to order. You got to plan, a lot more time how you're gonna get these things in, and release orders a lot earlier. So it's tough, right? Long lead times can create the following problems. You got high variations, right? If you have a longer lead time, there's a lot more chances you either be early or late on those lead times, and it could be quite a variable type of event. I mean, maybe you have a 6-week lead time, maybe you get a product in 4 weeks sometimes, maybe 8 weeks sometimes. So you have to plan for having a little bit more inventory on hand if you have a long lead time item. So it's more investment. If you want to change the part after you got in, you're carrying a lot more stock. Maybe you want to do an engineering change on it or a phase in, phase out type of stuff. There's a lot more risk of obsolescence and scrap, and it's just overall harder to deal with long lead times, right? So it's a big issue for material planning professionals and manufacturing professionals. So a couple of quick tips. These aren't meant to be worldwide or problem solvers for everybody, but how to shorten your lead times just as a manufacturing type situation. Cap the amount of work in process, right? You can only do so much WIP. Once you hit that amount, then it's done. You're quit producing, right? At Bullard, we have these bands that go inside of helmets, and we have a taped area floor lined up. And when we put the last bin in there that fills up that floor, then nobody makes bands anymore. It's just, we got too much work in process in there, and that's it. So we just don't make bands anymore. So anyway, you can prevent excess WIP by releasing material into the line in amounts consistent with appropriate batch sizes. So in that way, you don't have material available for production to produce in excess, right? So we've had that problem before with some of our roll goods and cloth. Someone just keeps cutting and cutting patterns that go inside helmets. If you cap that and we don't bring the material in, then they can't actually do that. So now pull system, the next slide, and that's you're actually pulling product from someone else. Each workstation makes only enough to replenish what the next workstation is using. So demand comes from the forward workstation, the next process, right? So and it can work outside of that too. The customer orders a pull for you to produce that quantity at that time, no more, no less. So it's a pull system. Now, strategic buffer, we talked about that in theory of constraints. It's stuff like inventory you keep inside your production lines to buffer you in case maybe there's a processing time difference from station to station, or maybe there's a chance of obsolescence or scrap. Then high risk, and you keep a little buffer there to keep you going. So you still can keep a strategic buffer in and be a lean manufacturing company, but you need to make sure you don't have too much buffer there. Make sure you cap it, and work in process is only enough to support that buffer. So anyway, you need to count their cycle times, right? Each process has a cycle time. You want to make sure it's balanced as much as you can, and use strategic buffer inventory to balance that out if you have to. So now process flexibility. Hopefully your workers are cross-trained. They can move around a little bit. You got flexible machinery. You can move from station to station. And you do quick changeovers, right? At Bullard, we used to do a little bit better job of this, but it used to be people would work in a few different areas. They would be able to move quickly for a couple areas. In case one area got busy, one was slow, they could move them real fast. Now, synchronous pull system, I'm looking at 230, slide 230, uses takt time to control the velocity of flow and reduce the overall lead time. So in a pull system, each area has a designated time, right? You guys know the example at Toyota where you've got an automotive subassembly or automotive body going through a manufacturing plant, and then if there's an out of balance situation, someone may pull the and-on cord, stop the line, and wait for everybody to balance. So operation times have to be known; they have to be standardized, and one assembly workstation triggers production for the whole plant, right? Like a pool. So that's that. I mean, if you're out of balance, I've been over at Toyota. If you're out of balance a little bit, maybe you're okay. If you're running like a first of the Camry, say you're starting a new Camry model. I mean, someone's pulling the andon cord it seems like every 30 seconds or so because there's so much out of balance and need help. But 5 principles of lean: value, value stream, flow, pull, and perfection. So we're going to talk about each one of these. Value is just the overall theory of lean, JIT, kind of Toyota production management philosophy. Just the elimination of waste. You're trying to get your value. Value stream, we're going to look at value stream mapping. Flow is like a lean flow system, like a one-piece, single-piece flow. Pull is just what we talked about, and perfection is that continuous pursuit of zero defects and JIT. Oh, that's good things. So some major lean improvement tools: value stream mapping, pull system, setup reduction, and TPM. So stuff you guys may have heard of. Now, value stream map is pretty cool. It's just a very visual way you look at a process. Everything in a process is mapped out, and then you can go through and look at it and see what what's value added and what's not. They've got an example right here. A resin supplier moves product in, and there's a process, and look at each process: injection mold, trim, assemble, and pack. And each one of those processes, they hopefully add value. I had a similar product. I was working with Toyota. Took them on a plant tour and get down. It's an injection molding product, and I am panicking a little bit because after we mold the product, see a person with an X-Acto knife cutting the flash, like excess plastic off of the part. And I try to keep Toyota away from that area. Of course, the Toyota person I was with sees that process, and what's the first thing they say is, "We're not paying for that, so you need to fix that right away." So that's not added value. That should be fixed in the production process. So anyway. Value stream mapping questions. Does it add form or feature to the product? A competitive advantage. Is that something the customer is willing to pay for? So that's the critical way that you have to look at something. Does the task include accounting, handling, transportation, moving, storing, expediting? So those are non-value added activities. And what impact do improvements have on facilities and distribution centers? So now, reducing setup time, you've got internal and external setup. Internal is something that you can do, only can do when the machine is down, and external when the machine is running. So, stuff like stuff you can do outside of changing the fixture, and there's a lot you can do in external, but you want to try to convert external to internal. Streamline your internal setup and eliminate waste and adjustments. So, putting wheels on your tools is good. You can roll them fast. If it's physically possible. Some tools, of course, are not possible. Anything you can do, a changeover's coming, get your operator ready to make that changeover, and try to reduce the non-value added time by converting internal to external. Now, TPM, it's kind of the basis of TPM is an operator is in charge of that machine. That's the overall. They're doing their own preventative maintenance, should be scheduled preventive maintenance, and give operators a sense of responsibility for the machines and downtime right there. So that's TPM. And now we're going to talk about inventory ABC, inventory record accuracy. Talk about ABC management. Guys, from being in materials production, inventory records are basically how we run our business, right? Inaccurate inventory will kill an ordering system. It'll kill your financial statements. It's hard to plan for anything. If you can't trust the system, what can you trust? As someone who's going through an ERP system change right now, where you can't visibly look in the system and trust your inventory levels, then, we're really having trouble, and the basics of 101, production we're having trouble with. So you got to have inventory record accuracy. A perpetual inventory record is where, your inventory changes from day to day, and that's accounted in the system. In the old days, you used to have maybe a daily or a weekly type reconciliation where inventory was only reconciled once a week or so, so it's changed over time. Cost of inaccurate records, lost sales, excess production, low productivity, high inventory, expediting shortages, schedules, late delivery, excess freight costs, obsolescence, right? You guys know all these. If you have bad inventory records, you have big problems. Now, cycle counting versus periodic inventory. Periodic inventory is like a physical inventory. We do once a year physical inventory, mostly to appease our auditors. But cycle counting, you got people who are experienced. They're reconciling stuff fast. They're finding problems. It's the apex recommended way of doing business. Timely detection, fewer mistakes. You catch stuff faster, and less chance of shutdowns. And so cycle counting is the way you want to go. Sources of problems. Why are there inventory inaccuracies? Poor design of forms, carelessness, inadequate storage space, timing for cutoff, untrained personnel, poor document control, items not properly identified, lack of discipline, right? So, I know just from my first-hand experience, people on our off shifts, our temporary people, maybe have not been trained like our first shift veterans. They don't know the importance of inventory accuracy. They may not fill out a scrap ticket. They may, something might come at nighttime. They may not receive in. So it's not all their fault. It's mostly a training issue, but there's a lot of things that can happen, and everybody's got to be in this common goal and know how important inventory accuracy is. When to cycle count? ABC classification, your high dollar value items are A's, mid value are B's, and most of your other items are C's. At reorder time, upon receipt of stock, that's when you cycle count. Balance is zero, negative balances, or if you have a lot of transactions. So, using ABC analysis to classify inventory, you have a high percent of dollar values. 80% of your dollar values are A's as far as dollar signs, but only 20%, 10 to 20% are the number of items. So you got few items make up the high value items. For us, the camera cores that go in our thermal imaging cameras we sell for like 10 grand, those are our big A items. B items are the middle ground items. They still count for a lot of your dollar value, and C's are like nuts, bolts, screws, stuff like that. So anyway, A's, B's, and C's. So that's where we're at right now. So uses of ABC classification: cycle counting, customer service, engineering priorities, replenishment systems, investment decisions. Here is a sample report right here, and you'll see in this example you got parts 1 through 4, and you see the cumulative percent of items is the dollar amount. There's 20% of your items. So see, these are the high value items 1 through 4. So you have the first item is $230,660, and you got 4 line items that are really high value items. Then you see how it goes down. So you would want to cycle count the top items, dollar items, a lot more than the other stuff. So problem 2.1, they've got a question for you. What would you place the cutoffs between A and B items for the purpose of cycle counting? In the book it says anything between 10 and 20% is good for an A item, and B items are 20%, and C is 60 to 70. So 10 to 20, if you're in that zone, no problem, and then 20% for the B's and 60 to 70 for the C's. So what overrides would you place an item in higher or lower category for cycle counting purposes? Well, you can move stuff around, right? If you have a critical item that's a C even, it's hard to get, even if it's low value, you may push that into an A item for cycle counting purposes. It doesn't have to be a high value item. Or maybe you've got an A item that's just such readily available, and the way it flows is accurate, and you can move that. There's no laws, This is a system we put in Buller when I first started. This is a system I put in, actually. And I override stuff all the time, right? I had some C items that were so critical, I had to put them as A items, and I reversed them around. So it says identify the anomalies of this report. We're just looking at the year's supply on hand. If you're a material planner, you'll see there's some items like item 18, 17, and 14, and the 10, 11, and 3 that you have just a very small amount of goods on hand. You have year's supply on hand. Like 18, you got 0, right? You don't have any items. You have 6 pieces of 17, and 14 is 6. So this is tipping you off that you either got an inventory problem or you need to order some stuff fast. So, cycle counting process: education, accountability, responsibility. Method of counting, you should have some kind of standard where you have a method of counting, frequency of counting, items to be counting, timing of cycle counts, and someone should just have to sign off on cycle counts, right, if there's a big discrepancy. So again, with ABC and cycle counting, education, understand the adverse effects of inventory accuracy, and try to determine the root causes. And who is responsible for transactions? Who generates cycle count reports? Who is informed when discrepancy occurs? Who approves discrepancy adjustments? Those are the type of things you got to answer. Now, bin examples. Where can you put stuff? Space on a shelf, a vat, space on the floor, outdoor space, or designated space on a rack. Now, bins, you may look in your system and you can say, oh, we're in A1, and it'll take you right to the right place for this stuff is, or it could be random. And so there's a lot of ways you can do it. You can have a fixed system where something is in the same place every time. You can just go right to it. You can have a random where things can be anywhere. It's assigned anytime, and it could be, you could go in your system. You can look, it's in B1, A1, wherever, and go find it. A zone is certain, it's random within just a zone. It's kind of a mix between fixed and random. So you may have an area where all your screws and nuts and bolts are at, but they might be in different places, but they'll be in that general zone. So anyway, that's that right there, gang. I'm not going to go over problem 2.2. I'll give you the solution to that. You guys should know that pretty good. Automated storage and retrieval system. Sometimes driverless cart racking systems, pretty automated stuff. There's some pretty neat stuff out there. Warehouse management systems where you can get stuff. Barcoding at the bare minimum. Usually, almost everybody's doing that barcoding where you can find stuff, pretty fast. Scan stuff into a particular location. RFID. We do this for the government right now. Because they have such large warehouses, you got tracking signals, and usually RFID will tell you exactly, like a GPS tell you exactly where something is going. Your automotive folks do that a lot too, RFID. So gang, that's it right there. That's inventory planning. Appreciate you hanging with me for a little while, and we'll get back to it later. Thank you.